All right, guys, I'm finally ready. You guys ready? Multiple choice. Here we go. I'm gonna hit the first couple quickly. This is what you have on your desk. What's the first answer? Number one. Oh wait, guys, thank you. Number one is A. You guys can do your oxidation states fairly easily. Oxidation state of, this is not permanganate, by the way. Why is this not permanganate? 2 minus charge. So permanganate has a 7 plus as its Mn oxidation state. This one has a 6 plus. That's permanganate. So just don't be distracted by the first answer. 2, which is the correct one? B, you guys can do your oxidation states, I feel. I'm giving you a couple of samples because you'll see similar questions like this, just simple oxidation states, and then more specifically, this one with the reaction down here in a second. Number 3, D, what's the oxidation state of that nitrogen? Plus 5, what's E's oxidation state? Plus 2, what's A's? Plus 4, B. Plus 1, and nitrite. Trite. Plus 3, right? Okay, so you can do that. That should be like a 30-second question. In terms of this reaction, I think we saw this one on one of the practices we've done. What was your answer? E as an elephant? Okay, so carbon is oxidized. Permanganate is the oxidizing agent, because permanganate itself is what? It goes from 7 plus to 2, so it is what? It's reduced. Remember, oxidizing agents are the ones reduced. Reducing agents are the ones oxidized. None of these other ones, some of these other ones didn't even make sense because your hydrogen's not changing. It's plus 1, so anything with hydrogen's out. So the first 3 are out immediately. And then manganese is oxidized, and oxalate is oxidizing agent. You just have to do your math. And so I think you could figure that very easily. 6 was the big boy. Oops, sorry. 5. 5 is which one? C, how did you know that? The sulfurs, thank you. Sulfur goes from a plus, what on the reactants? Sulfur goes 6 plus to a, sorry, oh yeah, because that's the one that's not, sorry, does not represent oxidation reduction, so it doesn't change oxidation state. Calcium doesn't change in oxidation state, so if it doesn't change oxidation state, it's not a redox reaction. Generally, all of our double replacements are non-redox because double replacement just changes ions. Do they change their charge? In a double replacement? Do they change their charge? No, so then that in fact means it doesn't change oxidation state, therefore it doesn't have an oxidation reduction component. Okay, tell me your thought process here, and I'm going to write down your thought process on the board because you will see one like this tomorrow, okay, on your multiple choice. So I need that, okay. Pinky, you start, honey. Tell me your thought process. Yeah. I want to know thought process. Who can guide me? Okay. Alvin, man. You like cheery. Well, I will start you off, people. Okay, we have solid metals A, B, C, and D, and their nitrate solutions. Metal D was placed in each of the solutions, and the observation of a reaction only occurred with A and B. So write down this thought process with me with like a little helpful guide. So D reacted with A2 plus. Okay, that one reacted. D reacted with B2 plus. That one reacted. Okay, so we know those reacted. What does that tell you about D in terms of activity? It is active, right? What does active mean again? We learned this Friday. So give away electrons means it is oxidized, so it is a blank agent. Reducing agent. Remember the question down here is regarding reducing agents. We're going to get there in a second. All right, so D, so this is our thought process. D is active, meaning it's able to oxidize, meaning it's a strong reducing agent. That's kind of your thought process there, okay? And as you go, metal B did not react with any of the solutions. So what does that tell you about metal B? So non-reactive, keep going. These are all 2 plus, by the way, okay? So this is a no reaction. So what does that tell you? If it's non-active, what does it tell you about its strength as a reducing agent? Weak reducing agent. Okay, so doesn't it go from strongest to weakest? Yeah, okay. So strongest reducing agent to weakest reducing agent. B is the weakest reducing agent. Point blank, we haven't finished this question. You've eliminated all choices but what? C and D are the two that you have right now, because B is the weakest reducing agent. Okay. I can't read that question. Metal C reacted in the solutions containing D plus ions. So metal C reacted with D plus, D2 plus, so that one reacted. So what does that tell you? So C reacted with D, but D didn't react. Well, it didn't say it only. But it doesn't. Oh no, but it says metal D was placed in all solutions. So that means specifically D plus C plus happened. Did not happen. No reaction. All right. So if C reacted with D and D did not react with C, who is more active? So C is more active than who? D. But what about A and B? More reactive than B for sure, because B is the weakest reducing agent. So from this logic here, we'll start with this one. If C is more active than D, C has to be before D. So then where does A go?
Right after.
Why right after it? Well, why couldn't it go before it? D reacted with A and not with C. Okay, so D reacted with A but not with C. So A has to be more likely be reduced than D. But regardless, once you figured out two of them, I think it really helped narrow down. Because D, CDAB is C. Okay. So once you figured out one of them, it was a trickle-down effect. And then after that, you really could narrow it down. But these half reactions, like kind of writing down reacted or didn't react, is what I might expect to see like for a pre-response, showing a word, showing your logic, justifying your answer, things like that. Okay? Okay. You like shake your head, so that's all I know. Okay, thank you. 7 had a typo in one of the options. Did anybody find the answer for 7? The answer should be no, okay. And then as you were going, I want you guys to tell me what would be the answer currently standing? Well, if you had to make one option for these Roman numerals. 3, so what is CH3OH, by the way? Organic compound. You're like, what's organic? 1 carbon. Meth. Thank you, Alvin. Methanol. It's an OH. Okay. So methanol is the one that's that's correctly balanced. How would you balance 1? Add 2 electrons on the product side. So would that be oxidized or reduced? Add them on the left side. Would that be oxidized or reduced? Because it's gaining electrons, right? Electrons in the reactants are reduced. Electrons in the products are oxidized. That should be a quick thought. And then this one's definitely what? Oxidized or reduced? Definitely reduced, right? Reducing the charge. That one's not even balanced, right? Okay. And then is 4 not balanced? No, the electrons are on the wrong side, correct? Okay, and then how would you make 5 work? The way it is, but make it work by changing a coefficient. 6H plus, right? So you can easily check those, but yeah, truly it was just 3 was the right one. All right, so I'm gonna stop on that for a moment. I know you guys want to go over some of your unit reviews, so I'm going to try to tackle a couple of them, but also I have put the keys up online so you can check yourself tonight, whatever questions you need, but I'll also tell you exactly what's going to be on your free response so that you're aware and multiple choice. Before we do that though, I'm going to give you guys 20 minutes, and that's it. And I want you guys to come up with an idea that relates redox to real life. And it can be really anything, absolutely anything, but you must demonstrate 2 things for me. If possible, please embed it in the global chemistry. Okay, I already have one person that claimed that as their idea of they're addressing on their own timeline, but I need 2 things from you. Oh, actually, I have this pulled up separately. I have this pulled up in another document. So can you guys first create a public service announcement of the redox, application of redox to real life? And what I'll do is, I was going to say in lab groups, was Lucas in a 4-person? He was in a 4-person? Okay, so in your lab groups, go. Come up with an idea first. And then you're going to write down the reaction. You're going to have an explanation of the relevance. You're going to have a picture. Why am I doing this the day before the test? Because you will have an opportunity to express that again on your test for extra credit. So I mean something that's pretty complete thought. Go ahead. I'm going to go ahead and put the actual instructions on the board. And I got to look and see the other questions we have on the unit review. You guys are moving slow. Let's get this party started. If you want a laptop, grab a laptop while you're sitting at your computer. That's just for you to know. You will see Beer's Law again. And then, sorry, I'm going to get back here. And then from the free response standpoint, you have 4 reactions you're balancing up front. One is oxidation state balancing, where you take the oxidation states and you do the little brackets, and then you put oxidation or reduction, you add your electrons, and you did your temporary coefficients with multipliers. Basically our first style of balancing. It should be an easy one. Balancing an acid and base, I give you 2 ones that you will be predicting the products of, but they are easy. So what are some things if I say something, you guys tell me what you predict, okay? So a metal is oxidized. So it goes to its highest cation form, right? A halide, halogen, is oxidized. It goes to its diatomic form. Permanganate always goes to Mn2+. Chromates or dichromates, Cr3+. And I saw the confused, like permanganate in acid goes to Mn2+. In permanganate in base, we've only seen once, goes to MnO2, and that's that brown cruddy stuff, right? What else have we commonly seen? That's probably the most. Oh, iron, like iron 2 to iron 3, or so. Like if I give you an ion, it's going to get to its highest oxidation state as well. Yeah. So things that we've used like 3 to 15 times. Those are the ones that I would be giving you. Some of those that I just named off. Activity, so an observation based, like I tell you a reaction, I'll say what should your observations be? This is kind of like a bit more descriptive chemistry where you're talking about what you see. Beer's Law again. Can you imagine what Beer's Law questions might look like on free response? What could I ask? Find the absorbance, okay, or I will always give you the link of the QDAT, but I could ask you to calculate it. Think bigger, more than just calculation. Okay, so what's the graph look like for Beer's Law? Thanks, Alvin. Anybody else? What's the graph look like? Oh, so I could ask for the absorption. I will give you that peak absorption. That's going to be used to make something else. That's used to make that series of observance data points. So the direct correlation, what are the axes? Observance versus concentration. Okay, I could also ask you for what? In a lab-based setting, what do I always ask for? Okay, I do always ask for safe. Thank you, but what else? Okay, think at the end of the lab, error analysis. I could ask you if the absorbance read blank, but it's blank. Why? So thinking back to your error analysis. So if you can go back and look from your labs from Friday, do that. That's why I really held lab day for Friday, so you could have a chance to think about that. Redox stoichiometry. Redox stoichiometry, we did something in our brass lab where you had to go through and balance. And then what? What did you do in your brass lab? You found the overall percent composition, but how did you get that far? You couldn't just go straight to percent comp. You had to find the mass of the compound of that substance that was reacted. Well, how did you get the mass? From the... Oh, that's a titration lab. Hold on. So you got the mass for the copper from the moles of copper, but how did you get the moles of copper? From your overall redox stoichiometry balance chemical equation. Right, where you do 2 half reactions, you add them together. So basically stoichiometry, and you guys have a couple samples there. Or instead of asking you for percent, I could ask you for molarity, which would be easy because at the end, if you got to moles, what would you then do to get to molarity? Divide by what? Liters, thank you. So nothing, I don't think anything crazy new, but it's very cumulative. And then one of your extra credit questions will be related to redox and real life relevance examples. So be able to explain your stuff that you just discovered. Okay. All right. So I am choosing now to go over. I've got to go over this. So pull out a piece of paper. This slightly sickened me. I'm gonna be honest with you. So I'm going over this quickly. Make sure you're taking notes down. So when I give you your free response back, it's an easy transition to correct. What are the 6 strong acids? AJ, tell me one. Hydrochloric. Kirk, tell me another. Let's go. Alvin, tell me another. Sulfuric. I can't write on this. Hydrochloric. Sulfuric. Kirk. Did you say sulfuric? Hydro what? Hydrobromic. Allie, tell me another. Hydroiodic. Jack.
Nitrous.
Thank you, Vicky. Perchloric. Thank you. Which of these? There is one that is polyprotic. Read on. Thank you. Poly means what? Multiple. Protic refers to protons, right? Protic referring to protons means just simply hydrogen. There's one. That was the only one that should be circled. You can do your bases. They look like a lowercase b. If you haven't memorized those yet, get on board. Activity series. Some of you guys came up with some crazy crap to put up there. Activity series. There are general trends, and that was on your video. So that tells me that half of you guys didn't watch your videos. If I'm expecting you to watch your videos so we can do more practice in class, that's a sacrifice so that we can have review time at the end of the year. I already tracked out towards May 1st, and our exam is. I have 2 weeks to review right now because I try to give you more time in class based off questions, based off your needs, based on your sleep. But I need to start picking up the pace a little bit here because right now I know I'm on struggle race because I didn't teach all of you. And I know my students who have me has this base knowledge, but I can't guarantee everyone has that. So I'm really trying to accommodate for the fact that I've not taught all of you. So if I'm asking you to do something, it's really important because they get you really, really great background information. General activity series. Pinky, start. Group 1A. Jacob, next. Group 2A. And Sean. So I'm going to just say aluminum because there's just group 3A, which really is only aluminum. Really? So group 3A, which is simply aluminum, and then row 1 of transition metals, and then row 2 of transition metals, and so forth. Copper surprisingly low. That's the general trend. There's a 2-point question, so if you got it wrong, no big deal. But if you got this one wrong, 7 points, that was an easy 7 points. This one, it requires you to write out reactions in terms of their NIE, but the NIE, you cannot ionize anything but what, and what. What can be ionized? Anybody? Thank you. Right, strong acids, strong bases, and soluble salts. That's it. If it's a gas, don't touch it. If it's a liquid, don't touch it. If it's a solid, don't touch it. Like, those things are not aqueous forms, so they can't even begin to ionize. So, in this one right here, copper, I need to write on this board. How do I get this to work? It's like usually the text.
Miss Ann, Savannah Carter to come to the office for a minute, please.
Thank you.
Thank you.
All right, so you guys write down your reaction. Copper 2 chloride, solutions of copper 2 chloride and lithium hydroxide while I get this handled. I really just want to get through like half of this and then I'll be good. Okay, so copper 2 chloride and lithium hydroxide makes copper 2 hydroxide and lithium chloride. Balanced where? How? 2 for the lithium hydroxide, and that handles it, right? So when you see this, aqueous, what is this one? Hydroxides are generally insoluble, and you guys had your solubility rules, yeah?
You also gave it to lithium chloride.
Oh, thank you. Okay. So this is our precipitate. I even saw you guys do a little down arrow. Precipitate, aqueous. All group 1s, always are always aqueous. So everything will ionize, right? Except for copper 2 hydroxide, leaving us with copper 2 ion, 2 hydroxide ions, leaving copper 2 hydroxide, not balanced. So that's our NIE straight there. 2 ions, everything else is spectator. However, the details of this question tell you that there was an excess reagent. Hold on. I think I'm thinking about the free response, the third free response. What ions are present in solution at the end of the reaction? What ions are present right now? Copper 2 and hydroxide, and who was a spectator? Chlorine and lithium. So truly though, you're saying these are ions now, right? Are these ions after the reaction's over? No. Okay, so I'm thinking about ahead to another question, but these two are the two things that react to form the copper 2 hydroxide, but the copper 2 hydroxide is, assuming that this doesn't say excess no, it does say it. I knew this says it. Lithium hydroxide is limiting reagent. Okay, lithium hydroxide is the LR. If this one's the LR, meaning that lithium hydroxide is the LR, 100% of the hydroxide's where? In the precipitate. So it's not present out in the solution form. And the lithium is wiped out as a reactant, true? Okay, but it's a spectator. So it is it in solution? It's a spectator though, right? It's always ionizing, it's always there, it doesn't disappear. So lithium for sure, despite the fact that it's a limiting reagent, it is going to be just freely present because it's a spectator. Who are the other two things that if they're not limiting, they're excess? Who's in excess? The other reactant, right? So copper is in excess and chlorine's in excess. Chlorine happens to be a spectator, so we already knew it was going to be present freely in solution. But then this is where some people got caught up. Copper, yes, it's held up. It's held up in that precipitate, but there's excess of copper, right? So it's also not only there, but it's also in solution because it was excess. Got me? Okay. So there should have been 3 things that were present in solution. Hydrogen gas is bubbled. Our hydrogen chloride gas is bubbled through a solution of sodium acetate, C2H3O2. What kind of reaction is this? Say again? Double replacement. So it makes acetic acid and sodium chloride. Sodium chloride. So sodium chloride, this is a solution of sodium acetate, right? So the gas and this sodium, the gas is going to stay in our NIE. The sodium acetate is going to be aqueous, so it will ionize because it's a soluble salt. Sodium chloride, now because we've just mixed it with water, is also aqueous, so it's going to be dissolving because it's a soluble salt. How do I know it's a soluble salt? Group 1A, 100% of the time, sodium and sodium will always ionize. And then acetic acid. And I love, I think it was Emma. Emma put WA on top of that, so she knows a weak acid, but she shall not touch it. So, do you touch this? No. Do you touch this? Yes. Acetate stays, sodium is going to be a spectator, yes? I'm actually going to go ahead and just knock it like this. And this is acetate with the 1 minus. Chlorine with the 1 minus. Do I touch this? No, because it's a weak acid. Acetic acid stays. So your final NIE should be HCl gas plus acetate yields chloride, ion, and acetic acid. And then most of you guys named it correctly. That was fine. Potassium hydride, KH, 1 and 1, is added to water. And I'm going to write water as HOH so I can help you along here. What could happen here? Avery, what you got? The metal, right? The metal's a cation. It will only bond with an anion. So who's my anion in water, technically? Hydroxide. So we could form potassium hydroxide, right? Okay, so then that leaves this H and this H. What can they form? H2 gas. So this is a H2 gas. This is liquid water. This was a solid. And so what is KOH? It is a strong base, but what state of matter is it? It's aqueous because, right, it's a solid mixed with a liquid. That's going to make a solution, and a solution is an aqueous solution. Ooh, AQ. What do you ionize? The KOH. So simply splits. Does anything serve as a spectator? No, because there's nothing else to ionize, hence nothing else to cancel for a spectator. And that's balanced, yes. Okay. So this one, some of you guys got this right, and this is the one I was questioning if I should even keep the questions based on the gas test. What happens when hydrogen is detected by a flaming splint? There's a pop or a hydrogen bark. And I tried to give you guys some credit there, but in terms of the NIE, that's really what I was looking for more of. So I'm going to do the other two NIEs a little later. Let me go ahead and go to the FRQ. I want to train you better on FRQs. I did a lot of assuming. FRQs, this is an old AP exam question, so for study evidence, maybe you Google old AP questions versus doing more of my work. And if you're cool with my work, then you should be okay. But if you're like, I totally screwed this one up, this is where you might want to help yourself in a different way this time. So this is one that was on the 2013 released exam. We have our KI tablet, we had it dry, we had a precipitate form. So for the NIE for this one, I'm not sure that you can see this all the way. Let me blow this up some. The two reactants were KI and lead 2 nitrate. Who was added in excess? Can you read that? So who was added in excess? Or lead 2 nitrate? So Ki plus lead 2 nitrate yields what? And gosh, I don't need that marker on my pants. Lead 2 iodide, that's our precipitate. Lead is a heavy metal, generally will be precipitating. And then 2 there, 2 there. Okay. It says excess of nitrate is added to the solution, so this is where I saw a couple people, okay, that's an excess, that's a good point to make because the details up here are very important. NIE, all your NIE should have been was 2I, one person didn't put U2, lead 2, and lead 2 iodide solid. Good? Okay, we are okay with that. Why do we write this as an NIE? It's very important, and this was worth 1 point for the NIE, 1 point for saying something about the fact that spectator ions are not truly involved in the reaction. So we write the true reaction, the compounds participating, the ions participating in the NIE. So saying something about a spectator ion, or the combination of that with the true reaction is what you got your point for. And I just follow the AP rubric, and I grade you like an AP rubric grades you, not how I want to give you points. Okay.
Miss Enlow, I need Courtney Weber to come to the office with her book, please.
Thank you. She'll be there in 7 minutes.
Thank you.
Thank you. Second, explain the purpose of drying paper. So why would an AP question specify drying paper in a data-based question with a big data table, and knowing that in the end it's calculating something about the precipitate? Why are we drying this? Okay, so we're talking about data. So who's taken an AP test before? A science AP test. Okay, a couple of us have insight, and others we're working towards. Okay, so if it's talking about data, and it's asking about drying, so it's talking really about, in the end, what's going to happen. If I have too much water left in my sample, it's going to skew the data, which would increase or decrease the percent of the iodine in the potassium iodide tablet. So talking about skewing data, talking about the fact that water is there is going to affect the end result, something like that. Some of you guys just said we're supposed to go into a constant mass, but you didn't say why. So I'm saying the explanation basis is there. Which is greater in solution, K plus or nitrate? A lot of you guys said it was equal because it was a 1-to-1 here, but it's not this that's causing the solution to be to change its concentration. It's the reactants that you add, right? So if you add excess of lead 2 nitrate, what are you going to have more of in the end? Potassium or the nitrate? The question says potassium or the nitrate. You're going to have more nitrate, and a lot of you guys worked too hard on that question. You were working, doing VDAs and big, huge stoichiometry-based boxes. It's literally in the question. If you have excess of this, your K plus is less than your nitrate in the end. And also your phrasing does matter. For me, it doesn't, but for the AP exam, they said this is K plus greater, less than, or equal. So say K plus is less than nitrate. Don't say nitrate is more than K plus. Because that's just the way it's phrased. The phrasing, but they want you to answer the question. And then lastly, my board is frozen here, okay. On the part where you're talking about the moles of precipitate that's produced in the experiment, moles of precipitate produced in the experiment is coming from the data table. The data table tells you mass of thoroughly dried filter paper versus mass of precipitate in this experiment. So don't go from the very beginning. We're like, oh, I have this and I have this, and let's do the limiting reagent and let's go forward. It's from this data. That's what they gave you data. If you don't use the data, you've done something wrong, because that's what they gave it to you. So take your total, subtract your mass of your filter paper. That mass difference got you 1 point. The second point came from taking mass of PBI2, which was the precipitate, and turning it to moles, converting it to moles with a smaller mass. You guys are working really hard on that question, and I know you know your stuff. That's like if I say, if I answer this question like an apple is red, I'm right? An apple is red. Okay, it doesn't have to be, but I'm not answering the question. Think about answering the question specifically with the data given to you. You guys are saying true things, is what I'm saying, but you're not answering the question. And then the second part of that was the mass percent of I in the tablet. If you were given, you got your mass and you converted it to moles of PBI2. Some of you guys just went with PBI2 and you found its mass percent. That is true, but it's not answering the question with the data given. So if they gave you the mass produced, turn that PBI2 with a 2-to-1 ratio just to I minus from the mass that you got in part D. You got me? So you're taking the mass and you're multiplying it by, or sorry, taking your mass to moles and you're multiplying it by the 2 moles of I over 1 mole of PBI2 ratio, and then that to grams. That's your true grammage of I minus. And then from the data given from the tablet weighed 0.452 grams. So take your I grams divided by your tablet times 100 will be your percent in the tablet. It was very specific when it said the tablet, not just like, oh, and let 2 I die. Okay? So I'll review a bit more of this with you, but I just want to make sure that tomorrow you're knowing, kind of getting that mindset of how do you do a free response question really. Okay? I've uploaded the keys for, go ahead and shut your computers down. You guys will, the bell should be ringing. Don't you know why the bells are not on? But I will get the Redox posters from you. Share them with me. And tonight for homework, you have complete the rest of your read for use if you did not. And I will upload on the website this specifically what I need from you. This is homework that I did not take out throughout the unit right here. I didn't take it up, so I want it now. And I'll upload that. Let me know if you do the office. Yeah. That was a packed. Yeah. I'm going to take up the active reading guide 4 because that was your very first assignment. Your problem sets that were related to balancing, your unit reviews and study evidence. So you have all of this. Keep your life organized. I'll update the website as well. I'm videoing. I'm gonna upload it for Luke. Just tell him he's good.